So today we're going to have a look at what to do when we need to solve the roots of a quadratic equation, but it does not equate to zero. So an example of this would be, let's say we have 3x plus 2 into x minus 5, which equals 28. And this does not equal 0, so we can't just solve for x because that's not going to give us the roots. The right-hand side must equal 0. So when we have something like this, what we need to do is expand it back to its original form. So that'll be 3x squared minus 15x plus 2x minus 10, which is equal to 28. And then we have to take 28 to the left-hand side so that the right does become 0. So we would then have 3x squared minus 15x plus 2x minus 10 minus 28, which is equal to 0. And now we can sort of simplify this, so that becomes 3x squared minus 13x minus 38, which is equal to 0. Now, in order to solve this, we now have a similar situation that we've had before. We have to factorize. So two terms that multiply for 3 times negative 38, and our 13 is our b. Right, so what are we going to do over here? So that is equal to 114, negative 114. That is our AC. And that is our B. So negative 13 is our B. So what goes into 114 with two numbers, but also adds to 13? So this will take a little bit of guesswork, which you can do by yourself, but for the process of this example, we know that the numbers we're going to be using are 19 and 6. So 19 times 6 is 114. However, 19 plus 6 is actually 25. So we know that one of these will have to be negative. So let's try negative 19 times 6. That's negative 114. Negative 19 plus 6 is negative 13. Right, so we can now simplify this into that form. Is minus 19x plus 6x minus 38, which is equal to 0. And then we can start grouping these. So straight away, there's one problem here. We've got a prime number, which is 19. So no number is going to go into 19. So the only thing that's common on this side is the x. So we have 3x minus 19. On this side, we have 2, which is common. So that'll give us 3x take, and 2 also goes into 38 19 times. So now we've got 3x take 19 as common. So we've got 3x take 19 into x plus 2, which is equal to 0. And now finding those roots is suddenly a lot more simple because we can now equate these terms to 0 because we have 0 on the right hand side. So x is 19 on 3. And then we have x plus 2 is equal to 0. X is equal to negative 2. And that is our second root. So that's sort of an example of how we solve roots for quadratic equations when we don't have the right-hand side equal to 0. And I'll see you in the next video.